Hello and welcome to the first in a series of videos on game development. We're going to be ultimately using Visual Studio 2015 with Monogame, but for the moment we're going to start with a console project, not a console in the sense of an Xbox or a PS4, but in the sense of the command line console, sort of like this, where you could type in text commands. Similar to that, or at least it looks similar to that. Which isn't very exciting, but it does get you used to some of the main concepts you need to get used to for programming in general and for games programming in particular. So I'm going to be using Visual Studio Community Edition 2015. So if you're using the Pro version, which you can get from DreamSpark, it's very similar. But if you're on 2013, you may find that some of the options, although they're still there, are in slightly different places. So this is the start screen for Visual Studio, and you can use it to create a new project or load up some of the projects we've been working on recently. I'm going to start a new project, and when you do that, you'll get a list of all the options. If you've installed it, Monogame will be there, but we're going to stick with Visual C# for the moment. So we've only got access to the built-in Visual C# capabilities and any other libraries we want to add. So when you click on a console application, it will go to the default location. You might want to change that depending on if you're, say, using this in a networked location and you don't want to save it to the network. And you can also give it a name. So I'm going to call this Ready. Click OK, it will create a project. You'll see on the right hand side here the Solution Explorer. This is where you'll get a list of all of the files that make up your project. And it will always start with a file called program.cs. C is for C#, of course. And this is the default setup that it gives you. The name that I put in for the project, Ready, is used in what's called a namespace. It's just a container for keeping various things, and it's got a name, so hence namespace. The curly brackets, if you click on them, you'll see they both turn grey to show that these two match up, and everything inside those curly brackets is contained within the namespace. You can minimize that by clicking the minus sign and expand it again by clicking plus. You can do the same thing with the using commands up here, but I'm actually going to get rid of them for the moment because what I intend to do is show you just the absolute minimum code you can put in to create a working program. And this bit here is also optional. I'm going to take these out. I'll come back to them later anyway. If you click start, you'll see it does run. It will flash up briefly on the screen once it's compiled, but it does nothing. So this is a working computer program. It is not terribly useful. So the first thing, as I said, the namespace is called Ready. Now if I was to change that, I can do so. I'm allowed to do that. That's called an identifier, and I choose what the identifier is. The bit in blue though, it's blue because this is a keyword. You're not allowed to change this. If you try and change it, you'll see that blue goes away and you get this nasty red underline that shows you there is an error. There are some options to try and fix it, but none of them are correct. Simply typed wrong. So there's your namespace. You'll notice that although I've changed the namespace, the project itself has still got the original name in, and the solution as a whole also has the original name in. Basically, changing the namespace does not change the name of your project. It's just the name of the thing that contains everything. So inside the namespace, you have at least one class. There's other things that can go inside namespaces, enums, structs, delegates, etc. But we'll keep it to the basics, as I said. This is a class, that's a keyword. Program is your identifier. It's turned this sort of cyan colour because even though it's an identifier, it's now the name of something that an entity that you can use or reuse. We can change that as well, though. And that's fine, not a problem there either. And inside the curly brackets for the class contains this thing here, which is a static void main. That's a method. Some people call it a function. Function is a slightly old-fashioned name for it, but a method is basically a function that belongs to this class. And every C# project must have a main function, a main method. That's where it runs. And it must be static, because static means that it's created straight away and it exists as long as this program is running. So you need a static main, and the void just means that no information comes back out of your method. You can actually change that. We can make it an integer and it can return a number. So instead of nothing coming back out, some data might come back out of this method. You can see that it's got a red error now, and that's telling us because we're not actually doing that. It's not returning a value. Well, we can make it do that. We can return value -1. That's a common number that might get returned as an error code. But what we can't do is we can't change it to a non-numeric thing. We could put in a string. A string is a valid data type, and we could try and return a valid string, like the word hello. And if I try and build that, it will give us a complaint, an error, saying it doesn't contain a static main method suitable for an endpoint. There is a static main method, it's just that it's one that's not suitable for the program to enter. And that's because it must be a void or an integer return value. Okay, so that's the minimum you can possibly do. We can also take with the static, by the way, and that'll have a similar kind of error. Let's build that. No static method. So it needs to be static. Try and avoid statics, generally speaking, but we do need this one here. Try and avoid them at first, at least, anyway. But we do need this one here, because the main method must always exist. Okay, so I mentioned data types briefly. There's a few different data types: integers, floating points, characters. I say it's char for short. Some people call it char. I disagree. Strings, which is multiple characters stringed together, and then various other ones, but they're the main ones. So the next thing is we can use this console that I was talking about. So we could say console.writeLine, and it doesn't like it because console doesn't exist. Remember I took away all those using commands? Well, if you show the fixes for this, using system will fix that. Console does exist, it's not built into C#. It's built into this system namespace here. So you hover over it, you get that pop-up saying namespace system. So we've got two namespaces now. One of them we are creating, and one of them is made for us called system, and that namespace contains a console which we can now access. If you'd rather not do that, you can put the full path in. Oops. And that will work just as well. That does make your code a little bit more verbose, which means wordy, mouthy. So I prefer most of the time to fix this with a using command. So when I'm telling the console class, and again you can see it's a class because it is that sort of cyan color, and if you hover over it, it pops up saying class. So the console class is also static, it always exists, and we can use the dot operator here, which is used to refer to attributes of the console class and methods and stuff like that the console contains. One of them is writeLine, which writes a line of text to the console, the screen. And if it's got empty brackets, those are the parameters, which is just data going in to the writeLine method. And if we don't pass any data in, then it will write a line of text, but that line of text will do nothing. In fact, I'm going to use the console to read a key as well. By the way, I pressed the tab key there to finish off that sentence. While you're typing in, this box here called IntelliSense will pop up, and you can click, or you can use the arrow keys to move around, and when you find the one you want, you can press tab, it lines it for you. It makes sure that all the caps are in the right place and it's spelled correctly. And the semicolon on the end is called a terminator. Every statement must have a terminator on it. Well, no, that's not quite true. Almost every statement must have a terminator on it. And that means the end of the command. So the read key is going to tell the console, wait for the user to press something. So when I press run, it's now got to that line, and it's waiting for me to press a key, which I will do. Bing, gone. Now writeLine, if we put that bracket in, you'll see there's 19 versions of this writeLine command. There's the one we are using. No, nothing comes back out, it's void, but nothing goes in, the brackets are empty. If we scroll through, we'll see it can take a boolean, that's a true or false value. It can take a character, which would look like that. There you go, there's letter A. It can take a string, which looks like that. So single quote for a character, double quotes for a string of characters. There we go. And that's basic input-output to a text console. With parameters, return values, which we'll get back to later, and terminator symbols. You can also pass a parameter into the read key command. There's only two versions of this, one with no parameters, one with two parameters, which is a boolean. And if you were to say, well, let's see, determines whether to display the pressed key in the console window. True to not display the key, false if you do want to display the key. So if I put the word false in here, then it's going to run the read key a slightly different way because of that parameter. And whatever key I press, watch because it will only flash up briefly, whatever key I press does appear on the screen. Okay, so that's passing a string, a character, a boolean, integers and floating points are much the same. So what's next? Well, we're going to use some of those numbers. We can make the console beep. It's not just text, it can also make sounds, well, very basic sounds. We just say beep. It waits for us to press a key and then beep. Now the beep command again has different options. You can put in an integer, that's what int stands for. An integer is a whole number, so we can't put in 3.5. If we try and do that for frequency and duration, we get the red underline, different error message. Cannot convert from double to int. So it thinks this is a double precision number, which even in most cases we wouldn't really want double, we'd want a floating point. Get back to that later. But let's say 5,000, comma 1,000. So if you've got more than one parameter, you must separate them with a comma. And the two parameters are frequency and duration. If I put a 5,000 hertz or 5 kilohertz frequency sound for 1,000 milliseconds, it sounds like that, a little bit different. Okay, so these are all what you call literal values. This bit of text here, hello, is literally the word hello. That's literally a false value, that's literally 5,000. Literal values are built into your program, and once you've compiled it, you press the start button, they cannot change. These are not terribly useful for games where data changes all the time. How many lives have you got? What's your score? What's the strength of your weapon? That sort of thing. So we need values that can change. These are called variables. So let's, by the way, before I show you these, you'll notice the executable is still called ready.exe, even though I changed the project to Ready Player One. Luckily, we can change the title. Console.title is effectively a variable, and it's a string variable. It's a variable that belongs to the console, so it's called a property. And we can assign a value to it using the equals operator. So it will assign the value, this is maybe the name of our game. So a horribly original game name here. Click start. And there we go, we have our own title. While I'm at it, it's called Ready Player One, I guess that's what our text should really say. Now the difference here is this is a literal, this is also a literal. I hate typos. But this literal is being assigned to this variable here. We can also make our own variable. You need to tell it what type of variable you're making, a string, and you need to give it an identifier. Call it game title. So game title is going to contain this value here, that string of text there. And we can then say something like console.title equals game title. And that's going to assign the value from here through the equals sign to the title of the actual console itself. So it's now stored in two places, in case you ever want to change it or use it for something else. By the way, did you notice that green line? Let's take this line out. Come on, there we are. Green line is different from the red line. The red line's an error. Green line is a warning. It's warning us saying, by the way, you've got this variable here, and you've given it a value, but you've never used it. So that the program will run just fine with a warning. There's no joke about when programmers come to the bridge and it's out, they'll all fall in because they ignore warnings. That's programmer humour for you. Okay, so you can ignore warnings a lot of the time, but they do exist for a reason. In this case, it would be to tell us that we should really be using this variable for something, and that's what I've done. So there we go, literals, variables, and there's a variable, what's called a declaration of a variable there. You can declare them separately, by the way. You can say, here's a string called game title, and then afterwards change the value contained within the game title variable. While I'm at it, if you declare the variable here inside these curly brackets, then it is a local variable. Local variable, it's only local to this area here. If I move it outside of the brackets, let's cut and paste in here. So another wee second, that red line should go away. If not, we may have to manually build it. Of course, it has to be static. If your method is static and it tries to refer to a variable, that variable must also be static. Otherwise, you can't guarantee that that variable actually exists yet. All right, so if we do it this way, then we're declaring our variable inside a different set of curly brackets, and it's now a variable inside those brackets, which is a little bit bigger scope for that variable. And this is called a member variable because it belongs to the class rather than the method. Okay, so that's assignment, scope. Should probably put in a comment. Not a terribly useful comment. You should try and write comments that explain why you're doing something rather than what you're doing. But this is such a basic game, it's hard to do that. So this is an example of comment. 2 forward slashes gives you a single line comment, and you can put them onto existing lines of code. You can also make multi-line comments with a slash star, ending with a star slash, and you can put in between there anything you like. And that's all comments. In case you want to put in a big block, like who wrote this code or copyright information, stuff like that. Alrighty. I think that will do for now. Let's quickly recap on some of these basics. A namespace is where you can put things. It's got a name, and it's called a namespace. Here's a keyword. The default's to dark blue, but you can change that colour if you mess about with the settings in Visual Studio. This is IntelliSense, which I've used a few times already. Start typing and it will try and guess what it is you're trying to put in. It's a bit like autocomplete. You can use tab once to fill it out, or tab twice as it says here. Sometimes we'll add extra code to help you out. Identifiers are names you choose, and you can identify namespaces, classes, variables, all kinds of things. Here's a class. You can create the class using the class keyword, followed by an identifier chosen by you. Don't forget the curly brackets to contain the attributes and methods of that class. Indentation is important. You might have noticed when you put in a curly bracket, everything after that is in to the right a little bit. That's an indent, and every time there's a curly bracket, the amount of indentation goes up. That's not technically required, but it's quite important from a coding point of view to help you see at a glance where your code is and what it contains. We saw a static class there, sorry, not a static class, a static method, and you can make static classes as well, but if you don't say so, they are going to be dynamic classes, which means you create them when you need to. Dynamic class itself doesn't really exist, it's just a template for creating objects, and the object is the thing that actually exists in the computer's memory. Classes all have members, and there's two kinds of members, attributes and methods, which I think I've mentioned as I'm going along. Attributes are basically variables, so you put in a data type and a name to declare them, and don't forget the terminator. Methods are basically functions, so you put in a return type Quite often that's void, which means it returns nothing. In fact, come to think of it, I think when I explain the method signatures, I'll explain all this. There's the modifiers, the return type, the name, and the parameters. So modifiers include things like the word static. Static entities are created as soon as the game or program begins. You can never create another one. So there's always only one of every static entity. So basically it acts as a class and an object at the same time. So you, like what I said earlier about dynamic classes, where the class itself doesn't exist, doesn't apply to static ones. You can use methods of a class directly if it's static. So next up we have void. This is a return type, but not a data type. So it doesn't actually return any data, it's just letting you know it returns nothing. Which is a sort of a Zen-like difference there, but yeah, void means no data comes back out of that method. So the main method, every program has to start in the main method, and it must be a main method that is either void or integer, it must be static, it must be called main with a capital or lowercase m. The parameters must either be empty or exactly this, a string array. That's what those square brackets mean, or braces as they're called. So these are parameters. The parameters go inside the round brackets. Technically they're called parentheses if you want to be a smart ass. You give them a data type and you give them a name. They're also called arguments. Don't know why, really. And finally, return values. So there was void earlier, we could make it an integer and actually return a number. If you do put a data type in as a return value, you must put the word return in followed by a value that matches that data type. Code blocks. If you see curly brackets, these are code blocks. They contain, well, if it's a method, the code block will contain statements. A statement is an executable command. You can put in curly brackets on their own. I recommend you don't because it's usually considered a mistake. A few people use it deliberately, but it's usually seen as a slightly odd way to organise your code. Data types we mentioned: integers, floating points, characters, strings, true, false, which is booleans, and more. There's other ones as well. So an integer is a whole number, like the number 42. It's a 32-bit number. If you know your binary, that means you can store up to 2 to the power 32 values, which gives you roughly about 2 million positive or negative. If you go above or below 2 million or minus 2 million, then an integer number is not enough to contain that, and you will get some weird things happening. It's called an overflow if you do that. Floating points, or floats, are not whole numbers, they are real numbers which contain decimal places. A floating point must have the letter F after it, otherwise it assumes it's a double precision floating point. With the F in, it's a single precision floating point, which is a 64-bit piece of data. But you know, with decimal numbers, you can't guarantee full accuracy. Sometimes you will get a fully accurate number. For instance, if you're to store number 3.5, because of the way floating point numbers work, that will be stored perfectly. But if you put in the number 3.33127 or something like that, it's very likely that it's going to round that off slightly and you'll get some odd things happening from time to time. A character, CHAR, that's actually a Unicode character, which is 16 bits of data, which represents letters, numbers, punctuation marks, other symbols. Strings is a combination of characters. Booleans are either the keyword true or the keyword false. It's used for logic, named after Charles Boole. Console class is not part of the C# language itself, but part of the .NET framework, which is used alongside C# most of the time, if not all the time. It's a static class, the console, and it's got loads of methods like readKey, readLine, WriteLine, beep. You've seen most of them already. Using commands come at the top. If you don't put a using command in to use a namespace, then you must specify the namespace before accessing anything in it. Either one of these is valid, however. The dot operator I mentioned earlier is called a member access operator. It's a symbol used to access members of a class. For instance, you could do system.console, console is within the system. You do console.title, title is held inside the console. And to change it, you can assign a new value. When you want to pass a parameter in, it goes inside the brackets. This is an example of passing a literal string value into the writeLine method. And you'll notice you don't actually use the word string here. You never put in the word string, int, bool, whatever. You don't put data types in because the method already knows what the data type it's expecting should be. Literal values hard-coded in, like this. Variables are pieces of data in memory that are allowed to change. Constants are not. But otherwise they work the same way. What you do is you declare them by putting in a data type and an identifier. And if you put it inside a class, that's a member variable available anywhere inside the class. But if you declare it inside a method, it's available only inside that method, and it's called a local variable. And in fact, you can put them inside other code blocks, and it would be local to those code blocks as well. But let's not get ahead of ourselves. In fact, you can have different variables with the same name as long as they have different scopes. If two things have the same scope with the same name, then it gets tricky trying to make sure you're accessing the correct variable. Also, if you have a local variable, you can only access it after the line where you have declared it. Member variables, however, can be accessed anywhere within the class, and if it's set up as public, you can also access it from other classes by using that dot operator I mentioned earlier. So here's some examples of declaring variables. Integer called score, integer called live. Notice you can declare two things on one line by separating them with a comma. A floating point declaration, a character declaration, a string, and a boolean. You can also assign values using the equals operator. So the value on the right is what we call an expression. You need to evaluate that, and then it will be assigned to the thing on the left hand side, the variable on the left hand side. Lives becomes equal to 3. Score becomes equal to score plus 1. So for example, if your score is 10, the evaluation says 10 plus 1 is 11. Score equals 11. So that's how you increment the score. Or you can assign a string to a string, you can assign a true or false value to a boolean, etc. Other operators you can say plus. In fact, I've just mentioned plus, lives equals lives plus 1 is another example. This asterisk is the multiply, so score becomes equal to whatever the score is plus 10 times the multiplier. And this is where the order of operations comes in. If you put brackets around things, then it does the evaluation of whatever's inside the brackets first. So in this one here, score equals score plus 10 times multiplier, the times, the asterisk, comes first. But if you do it this way around, because they're inside brackets, the plus comes first. It will add the time onto the coins you've collected, and then multiply by the multiplier. And finally add on the bonus. You can get pretty complicated like that. Once it's done that evaluation, it then takes the result and assigns it, whatever that value that is, to the bonus value. It's usually a good idea to initialize variables. That means giving them an initial value. For example, when you declare an integer, we might give it a name of score and an initial value of 0. You could give a person an initial name. You could set the game over boolean to false. But you don't need to do that at the same time. You can do them separately if you want. But if you don't do it and then try and use the variable, it will very often give you an error saying you can't use an uninitialized variable. This isn't a constant that I mentioned earlier. The difference is you must use the keyword const to let it know it's a constant. If you don't put that in, it's a variable. Otherwise, it's the same. The only other difference being you must assign a value to it immediately. You can't leave it hanging and decide what the constant should be later. That doesn't make any sense. You can't have a constant that changes. Here's examples of comments, multi-line comments, and a single line comment. And that's all for your first lesson.